Most of us expect global connectivity nearly anywhere, on any device, for nearly any purpose: texts, phone calls, email, YouTube videos. The journey to and from these devices is a long and complicated one. This is not achieved by one single network, but by a network of networks, multiple types of networks, operated by different types of companies. Covering the first and last leg of the journey are the so-called access networks. These are the last-mile connections, localized, distributed networks. In any given area, multiple different types of access networks are in use simultaneously, a result of how networks have evolved over time. The big split is wired versus wireless access networks. On the wired side, things started out with copper, old-school wireline used for telephone services and then later for delivering internet via the DSL protocol. Copper networks are still used in some rural areas, but the major carriers are fast phasing them out. Then came cable, coaxial wires initially laid for television and later used for the internet as well. Today, the most advanced option is fiber, optical lines that transmit data as pulses of light. Fiber offers higher speeds and reliability, making it ideal for modern, high-bandwidth use cases. In the US, cable remains the leading source of internet, but fiber is steadily catching up. In many parts of Europe, the cable phase was largely skipped altogether. Telcos there went straight from copper to fiber. Fiber is also already dominant in many Asian markets, namely China, Japan, and Korea. On the wireless side, you have radio wave-based access technologies used in the so-called Radio Access Network, or RAN. The specific technologies here have evolved over defined generations: 2G, 3G, 4G LTE, and 5G, with 6G in development. These are set globally by an industry body called the 3GPP. Each can be thought of as a separate network in many respects, though they often run side by side and share underlying infrastructure, such as cell tower sites. For telcos, the move to each next generation requires a costly rollout, and usually a period of running multiple networks simultaneously. Older networks are typically phased out eventually, but in some cases, like in parts of Europe, 2G and 3G networks are still maintained, acting as a fallback system for voice calls. In recent years, the latest technology includes satellites and drones. These are the non-terrestrial networks, or NTNs. They function as both standalone networks, say for home internet in Starlink's case, and as extensions of the RAN, helping it cover remote areas. Regardless of the access network being used, information eventually needs to find its way upstream to the next layer, the metro networks, aka the middle mile. Metro networks, sometimes called metro rings, encircle cities and metropolitan areas, carrying dense volumes of data traffic at high speeds. If the access networks are like different tributaries, the metro network is like the main river. These connections are now almost always fiber. The different metro rings will then connect up through the next layer, the national and global networks. This is the long-haul network. This, too, is fiber. Across this network of networks, you have different network operators. The major telecom operators like AT&T, NTT, KT, Vodafone tend to do a bit of everything. Those that serve both wired and wireless access networks are called integrated carriers. There are also some players that focus on a particular type of network. For example, there are some companies that focus on access networks in hard-to-serve areas, like in underground metro stations or dense urban centers. These are the so-called neutral host providers, companies like Boyden Networks and Cellnex Telecom. They operate the network and share it neutrally with multiple carriers. There are also companies that focus on metro rings, like Lumen, Zayo, and FiberLight, or on long-haul networks like Windstream and Cogent Communications. This, too, is mostly a B2B game. These companies sell wholesale network access to other carriers. You also have hyperscalers like Google, Meta, Amazon, and Microsoft getting in the long-haul game, building national and even subsea fiber cables to support their cloud and AI infrastructure. This is seen as a threat to telcos, as it means less of the value will flow to them.